We are told a small ball is projected with speed u meters per second from a point O at the top of a vertical cliff. The point O is 25 meters vertically above the point N, which is on horizontal ground. The ball is projected at an angle of 45 degrees above the horizontal. The ball hits the ground at a point A, where AN equals 100 meters, as shown in figure 2. So we have our figure 2 here. We're then told the motion of the ball is modelled as that of a particle moving freely under gravity. Okay. Using this initial model, we need to show that u, so our initial velocity, is 28 for 6 marks. Okay. So just let's go through the question, pick up some key points. Okay. So we're going to say the initial speed is u. All right. We're going to pick up that the point O is 25 meters, so there's a vertical displacement of 25 meters. Okay. We're going to pick up the angle of inclination. We're then going to pick up that AN is 100 meters, so the horizontal distance is 100 meters. The motion of the ball is modelled as a particle moving freely under gravity. What this means is there is no air resistance. The only force acting on our ball is gravity. And then using this model, show that u equals 28, okay? When you have these questions, the best thing to do is to write out first what you know about your horizontal and your vertical components, okay? So by that, I mean, what we can do is we can say, so I'm going to use H for horizontal and V for vertical, okay? And then on the side here, I'm going to write SUVA, so S, U, V, A, and T, like this, okay? So, looking at a horizontal component, do we know the displacement? Do we know the displacement for our horizontal component? And yes, we do. That's 100 meters. So we're just going to write 100 here. Okay. Our initial velocity for the horizontal component, well, if you were to resolve this diagram here, the horizontal is the adjacent. So it's going to be u cosine 45. Now, because we know there's no air resistance, and because gravity acts downwards, not horizontally, we know that our final velocity will also be u cosine 45, okay? And from here, acceleration equals 0. Now, we don't have a time, so we're going to leave that blank, okay? So that's going to help us know what we need to find, okay? Now, let's consider the vertical motion, okay? So if we go from our starting point, which is this point here, this is where everything's starting, the displacement we know is minus 25 meters, okay? Because we are because actually we should have said first, taking up as positive, like that, okay? Sorry. So from here, we know that now, going downwards, so as you would fall down, you would go by a displacement of minus 25 meters, okay? So we have that. Next is to look at our initial velocity downwards, okay? Again, what we can do is we can look at our diagram here, resolve it. This is the opposite side, so this is going to be u sine 45, okay? We don't know our final velocity, okay? So we leave this one blank. But what we do know is that acceleration is going to be minus g. Okay, now the reason is because we're taking upwards as positive, but gravity acts downwards. So gravity being g would act downwards, so its vector would be a negative. Okay, and again, we don't know the time period for the projectile. Okay, so from here, what we can actually do is we can start by setting up some equations. So the first thing I'm going to do is I'm going to look at horizontal motion. So I'm just going to say using horizontal motion, like that. What we're going to say is we're going to use the rule that velocity, so velocity equals displacement over time. Okay, and the reason I've written out in full like this is because using the letters can tend to be a bit confusing. So it's better to write out the full words so you don't get confused. Okay, from here, what we can say, we know our velocity is u cosine 45 because there's no acceleration for our horizontal component, which means we can use a constant acceleration formula where the acceleration is 0. So we would end up with u cosine 45 equals, our displacement is 100, but we don't know what our time period is. So we're just going to write t, okay? This is the sort of the only concrete equation we can derive from our horizontal projectile motion, okay? Next, let's use our vertical motion, okay? Like this, okay? Now, what we can do here is we can actually use one of the Suvat equations, which says that S equals ut plus half at squared, okay? This is because we are given S as minus 25, we are given U as U sine 45, we are given A as minus G, and then T is something we will need to find in the end, okay? So let's plug this in. So what we end up with is minus 25 equals U was U sine 45, so U sine 45 T minus, so the reason it's minus here is because our acceleration is minus G, so we're just going to do minus half G T squared like that, okay? Now, what you might notice is if we're trying to solve this in terms of U and T, we can actually eliminate T using U cosine 45 equals 100 over T. Because what this will allow us to do is say that T equals 100 over U cosine 45 like that, okay? So what I'm going to do is I'm going to substitute for all instances of T like this, our 100 over U cosine 45, all right? So what we'll end up with is minus 25 equals U sine 45 times 100 over U cosine 45 minus half G, and then T squared is 100 over U cosine 45 like that squared, okay? From here, this U and this U cancel, and this term becomes, so this sine 45 over cosine 45 becomes tan 45. So in the end, what you'll be left with to solve is minus 25 equals 100 times tan 45 minus half G 100 squared over U squared cosine squared 45, like that, okay? From here, it's a simple case of rearranging the terms, and in doing so, what you would end up with is minus 25 minus 100 times tan 45 equals minus half G, and then 100 squared is 10,000, so 10,000 over U squared cosine squared 45. And in return, what you would get is you would get that U, if you were to plug this into your calculator and rearrange for U squared, you would get that U equals 28 as required. So this question is worth 6 marks. Your first mark comes from stating you're going to use horizontal motion. Your second mark comes from showing you've used horizontal motion. So to get either of these two forms we have here or here is correct. So there's that. Your third mark comes from stating you're going to use vertical motion. Your fourth mark comes from using S equals ut plus half at squared to get this line. And then your fifth mark comes from eliminating t, as we have done here, and substituting for u. And then your sixth and final mark comes from doing the necessary algebraic simplifications to get that u equals 28. Part B has asked us to find the greatest height of the ball above the horizontal ground NA for 3 marks, okay? So the first thing I'm going to start by doing is finding how high the ball reaches from where the level it's thrown, so O, okay, so this plane here, all right? And because we're looking at the greatest height, what we need to look at is the vertical component. So we're going to say, using vertical motion, like this, we're going to set up our SUVAT again, so SUVAT, t. And we're just going to look at the vertical component for now, okay? So the height above the ground for the projectile is h. And the reason this is positive h is because we have taken up to be positive, so the upwards direction to be the positive direction in part A, so we're going to keep it that way. And because this height h will be above our starting point of O, that means it's a positive displacement. U is going to be 28 sine 45. Our final velocity is going to be 0. And the reason this is because when you are throwing a ball, okay, before it reaches the maximum height, it is going to be decreasing in speed because gravity is acting in the opposite direction to it, okay? So once it reaches its maximum height and just before it falls back down, it is actually stationary for a very short instant, okay? And at that point, it's not moving, so its velocity is 0. The acceleration is minus g because it is going in the downward direction and our upward direction is positive, and we don't know t, so we can just leave that for now, okay? What we need to do is we need to use an equation which has s, u, v, and a, okay? And the only equation which has this is v squared equals u squared plus 2as. Okay, and we can use this equation because we're looking at constant acceleration, so that's just something you need to check. What I'm going to do, plug in our values. So we have 0 squared equals u squared, which is 28 sine 45 all squared, plus 2 times a, which is minus g, times s, which is h, like that, okay? We can rearrange this to say that 0 equals 28 sine 45 all squared minus 2gh, so just minus like that. Rearranging for h, what you would get is 2gh equals 28 sine 45 all squared, and that h equals 28 sine 45 all squared divided by 2g. And this will get you a height of 20 meters, okay? But careful, we're not done here because the question didn't ask what is the maximum height it reaches from where it's being thrown. It's asked for the maximum height from the ground, NA. And NA is an extra 25 meters below where the ball was thrown. So you need to say, okay, greatest height equals 20 meters, so h, plus 25 meters, like this, okay? This equals 20 plus 25, which equals 45 meters, like that. So this question is, so this part is worth 3 marks. Your first mark comes from stating that you'll be using vertical motion. Your second mark comes from correctly plugging in V, U, A, and S to get this line here. And then your third and final mark comes from getting a height above the plane is thrown from as 20 and using that with 25 to get 45 as the greatest height reached by the ball. We are told in a refinement to the model of the motion of the ball from O to A, the effect of air resistance is included. This refined model is used to find a new value of U. Part C has asked us, how would this new value of U compare with 28, the value given in Part A for 1 mark, okay? What we need to state is we need to state that the new value has to be greater than 28, okay? Because we need to account for the fact that the ball will lose some speed due to air resistance, okay? And for it to be allowed to reach the full horizontal displacement of 100 meters, it needs to be more than 28, okay? So what we need to say is very simple. Just say new value of U is greater than 28, okay? And this question is worth 1 mark, and you get 1 mark for stating that. Part D has asked us to state one further refinement to make the model, that would make the model more realistic, okay? So for this question, you can have a variety of things. Any reasonable suggestion works, okay? The most obvious one, which for these types of questions, which I can think of, is anything involving G. A more accurate version would be a more accurate value of G, okay? So more accurate value of J, okay? So you get 1 mark for this as your correct answer. Now, the other things mark scheme has included are just other examples are to take into account wind effects, to take into account the spin of the ball, to include the size of the ball and not modeling it as a particle, because when you model as a particle, you assume that the forces are negligible, and the shape of the ball, okay? So including all of these in your model could further refine it to make it more accurate, okay? But you get this mark for any, suitable suggestion.